GATE 2017 Civil Engineering Set 1 Question 34. The radius of a horizontal circular curve on a highway is 120 meters. The design speed is 60 km per hour and the design coefficient of lateral friction between the tire and the road surface is 0.15. The estimated value of super elevation required if full lateral friction is assumed to develop and the value of coefficient of friction needed if no super elevation is provided will respectively be. The four options given are A 1 by 11.6 and 0.1, B 1 by 10.5 and 0.37, C 1 by 11.6 and 0.24 and D 1 by 12.9 and 0.24. The relevant NPTEL reference has been mentioned. So if we want to design super elevation for a horizontal curve which is given as, so a car is moving on a horizontal curve of radius r where the road has been lifted by an angle of theta to counteract the centrifugal force developed. The centrifugal force P will act in a horizontal direction and the weight of the car will act in a vertical direction. By geometry, this angle would be theta and this angle would also be theta. So resolving the components, this component would become P cos theta and the vertical component of the force P would become as P sin theta along with the component of weight that would be W cos theta. Similarly, a weight will have a horizontal component along the incline that would be W sin theta. A normal force would act on the car in the vertical direction that is perpendicular to the incline. So it can be seen that P cos theta that is acting in the upward direction would be equal to W sin theta plus the frictional force that will act on the tires. Let us denote it by capital F. This will be given by P cos theta equals W sin theta plus the frictional force is nothing but the coefficient of friction into normal force. This would become W sin theta plus F into the normal force. So we can see from vertical symmetry that normal force would be equal to P sin theta plus W cos theta. So taking all the terms of P and W on one side, it would be P into cos theta minus F sin theta equals W into sin theta plus F times of cos theta. Finding the value of P by W, which is the same as the power to weight ratio that is given by V square by GR, this would become sin theta plus F cos theta divided by cos theta minus F into sin theta. Dividing in the numerator and denominator by cos theta, we would get tan theta plus F divided by 1 minus F into tan theta. Tan theta is nothing but the super elevation of the road. So this becomes E plus F divided by 1 minus EF. So when both E and F are very small, the value of EF tends to be 0. So the denominator 1 minus EF would almost be approximated as 1. So that gives us E plus F equals V square by GR. Expressing V in terms of kilometer per hour, we get V square by 127 R. Here V should be kept in kilometers per hour. So in this case, we have been given the radius of the road as 120 meters and the design speed is given as 60 kilometers per hour. The F value is given as 0.15. So as per the equation, E plus F is given by V square divided by 127 R. So substituting the value of V as 60 and R as 120 meters, we get the sum of E and F as 0.236. Case 1, where it is said that full friction is assumed to develop. In that case, the super elevation will be given by 0.236 minus F. So this would turn out to be 0.086. In case 2, when it is said that there is no super elevation, so the value of E would be kept as 0. In this case, F would be the full value, that is 0.236. This can be rounded off to around 0.24. 0.086 can be written as 1 by 11.6. So the value of super elevation is obtained as 1 by 11.6 and friction as 0.24. So the estimated value of super elevation required when full lateral friction is assumed to develop and the value of coefficient of friction when no super elevation is provided was found out as 1 by 11.6 and 0.24, that is option C. The relevant NPTEL reference has been mentioned.